this video for Computer Science 9618, we're going to create the ultimate linked list tutorial video series. This will go over every single way, or hopefully every single way, that Cambridge could assess you on your paper 4 exam in regards to the linked list. So this video series is going to go over every single possible way that I could think of that Cambridge could assess you using a linked list. Now in this video, video 1, we're going to be doing a linked list using a 1D array, and of course I'm going to code it out and walk you through the code to hopefully help make you more successful and prepare for that paper 4 exam. Let's go ahead and let's get started. So a linked list is one of the 4 abstract data types, and in Computer Science 9618 you're expected to know how to program on paper 4, a linked list of course, a binary tree, a stack, and a queue. So the video series is going to include all of these, going over every single way that I know of that they could assess you. That way you can be ready and feel comfortable about those abstract data types on your paper 4 exam. This video, of course, focuses on a linked list using a 1D array. Now, a linked list, we can't program it unless we know what it actually is. So let's go over how a linked list actually works. It's made up of an array, or it could be made up of a record. A 1D array could also implement being using a 2D array, or a record, which is our custom data types. Those are our composite data types that show up in topic 13. Now, each item in the linked list contains 2 pieces of data, or 2 items. It contains the data itself, what the actual data is that we're adding. This could be a name, could be a number, it could be whatever data type we want it to be, but it also contains a pointer. That's what each item is going to contain. Now, each pointer points to the next item in the list. That's what you'll hear people say. But more specifically, it's not actually pointing to the item, but the index of where that item is stored in the array. That's what it's actually pointing to. I hear people say all the time, oh, it points to the next item. Well, that doesn't really explain a lot. It's not actually pointing to the next item, but the location in the array of where that item is stored, and you'll see that as we move on a little later. Now, there are other pointers that are commonly used with a linked list. One is the start pointer. Now, every item in the linked list doesn't have a start pointer. It has data in the pointer, but then used globally or across the program are other pointers. And the start pointer, that's going to be one variable used across the program. We need to know where the first item is in the array that we're starting with. It may not always be index 0. For example, is the list alphabetical? Maybe the first name isn't in index 0. We may not be adding the names alphabetically, but if we want to traverse it alphabetically, we need to know what we're starting with. The next one is the free pointer. Which index is the next available index to be used? Remember, order in the array doesn't matter. It's all about the pointers pointing to the location of where the next item is inside our linked list. We also need to have a current pointer variable. Allows us to see where we are currently in the linked list. Referencing an index in the array, we'll be using that as we update pointers. And then we also need a previous pointer as well. This allows us to change pointers when inserting or removing an item from the linked list. So you'll see current pointer and previous pointer updated when we actually go to use them. All right, so here's going to be our linked list. We have a linked list of names. It has 5 indices. We have index 0, 1, 2, 3, and index 4. So if I count 0 to 4, that's going to be 5 indices in total. Right now, there's nothing there. I also have another 1D array because each item not only has data, it also has its pointer value. Now, index 0 is going to correspond with index 0 of our names. Index 1 in our pointer list will also correspond to index 1 in our name list. So this is going to be using a parallel 1D array. Because they could ask you to use a 1D array, you're going to have to use 2. One for the data, one for the pointers. Now we also need those other variables that we talked about. Free pointer, we're going to set it to 0 because that's the first available index in the array. We're going to start at index 0. Our start pointer is going to be -1. Why is it -1? There is no -1 in the array. Why is it -1? Because our linked list is empty. If we go to traverse the linked list and our start pointer is -1, we need to output a message saying, hey, there's nothing in the linked list. It's empty. There's nothing to traverse here. We also need our current pointer, which is going to be -1. We'll assign it a value when we use it. Same thing with previous pointer. So Remember, order does not matter here. It's all about the pointers, so it does not matter where it's stored in the array. Now, ours is going to be traversed in alphabetical order because that's going to up the difficulty, and that is a popular way that Cambridge will assess you on a linked list, is traversing it in order. So let's add our first name. Our first name is going to be Davida. So to figure out where to put Davida, we look at our free pointer, and we're going to do this for every name. We just look at our free pointer. Now in the program, that's going to be free PTR. This will tell us which index inside the linked list of names to put the name Davida. Well, our free pointer is saying, hey, index 0 is free. It's available to be used. So we look at the free pointer. It's 0. I go into index 0. What am I putting inside index 0? Well, I'm putting Davida's name. So Davida goes right inside index 0. Now I'm not done, because not only do I need to insert Davida's name based on the free pointer, which tells me which index to put her in, I also need to update her pointer. So I look at my 1D array of list pointers. So I look at index 0. I need to update it. So I'm going to look at index 0 right here, and I see it's -1. I'm going to leave it at -1. I can also set it to -1, but why am I setting it at -1? Well, Davida is the only name in the list. So -1 signifies that we are at the end of the list. Because Davida is the only name inside our linked list, there's nothing that comes after it. So she's pointing to -1, saying, hey, we are done with the linked list. There are no other names inside of our program. If we set our pointer to 0, she's going to point back to herself. Then when we go to traverse the list, it's always going to be index 0. Now, the next thing we need to do is we need to take a look at the start pointer. The start pointer was -1. But now that we have Davida inside of our list, we're ready to start looking at our linked list. Well, what are we starting with? The only item that's inside the list, which is going to be 0. The last thing we need to do is we need to take a look at that free pointer. Index 0 isn't free anymore. Davida is in index 0. I don't want to overwrite Davida. So all I need to do is increment that free pointer from 0 to 1. So let's program what we have so far. So we have a set of global variables here. We have a 1D array linked list. This is going to hold all the names. This is where we're going to put Davida. And then each name corresponds to the same index in a parallel array, and that's going to be its pointer, where it's actually pointing to the index of where the next item is located inside our linked list of names. We have current pointer, previous pointer, free pointer, and start pointer. That's everything we're going to need to be able to program out this linked list. In our submain, we've initialized free pointer to 0. Remember, that's pointing to where the first name is going to go. Start pointer is going to be -1. Our current pointer, -1. Our previous pointer, -1, just to give it an initialized value. Now, in the Cambridge exam, it will tell you what value to give those pointers. Then we have item as a string, and I put all of these are going to go into a separate procedure. That way we can see exactly what the code is doing and keep our code organized. The first thing we want to do is we want to check if the free pointer is not equal to -1. Because if it's not equal to -1, then I have room to add a name to the linked list. So I'm simply going to say console.writeLine. What name do you want to add? And then I'm simply going to do item equals console.readLine. Now I could do what item do you want to add? I could do name. I could do anything, whatever variable name you would like. Now, if it is -1, well, that's the else statement. If it is -1, then there's no room in the linked list. So I'm simply going to tell them that. There is no room in the list. Then what I'm going to do is I'm going to exit the sub. There's no point in running the rest of the code if there's no item in the linked list. We don't need to traverse the rest of the code for that. So the next thing we need to do is we need to check, is it the first item in the linked list? Well, how do we know if it's the first item? Well, we check that free pointer. We look to see if that free pointer is equal to 0. If it's equal to 0, I know it's the first item, so I'm going to add that. So I'm going to go linked list. Now I could do index 0. You can also do free pointer, whatever you would like. Maybe we're starting at the end of the array, working our way backwards. If that's the case, you would do 4 or you could do 0. It's up to you, wherever you want to start. It makes sense though to start at the beginning, but remember, order does not matter. And we don't want to add U10, we want to add item. There we go. The next thing we need to do is update, of course, that Davita's pointer. So we're going to do list pointer, and we're going to do that free pointer, which is going to be index 0, and we want to give it a value. The value is going to be -1 because that is the end. If she's the only person inside the list, and that's what this if statement is checking, then we know it's at the end of the list. This if statement will only run the first time when we're adding an item, because free pointer is only going to be 0 when we add it the first time. Don't forget, we said we need to increment free pointer by 1. Then our start pointer is no longer a -1. It is now 0, starting at the first item. We're going to say, hey, your item was added. We're not going to say, hey, your item was added. We're just going to say item was added. And then we're going to exit the sub. There's no point in doing the rest of the code that we're going to add in a bit if we're only adding the first name. That covers everything that we've done up to this point. Let's swing back to the presentation. Let's take a look at what happens when we add another name and not just the first name to the list. All right, let's go ahead and add our next name. Our name is going to be Betty. Now, Betty is going to come before Davita alphabetically, so we'll be adjusting some pointers to handle that. Now, to figure out where to put Betty, though, in our array, we look at our free pointer. This will tell us which index to put Betty into. So we look at our free pointer, we see that is pointing to index 1. So our free pointer, because it's pointing to index 1, we're going to place Betty into index 1 of our linked list array that's holding the names. Now, remember, with the array, order does not matter. Yes, Betty comes before Davita, but we're not using an array here. We're using an array to illustrate a linked list, but the data structure we're building is a linked list. If it was a regular 1D array, we'd have to go ahead and resort it. With a linked list, you don't. All you need to do is add another item and then update some pointers. So we're going to go ahead and add Betty into index 1, but now we need to look at those pointers. 2 pointers may or may not need to change because we just put in Betty. So what about index 0, that is Davita. What is her pointer going to be? We need to solve that as well as Betty's pointer. So we look at Davita. Davita comes after Betty alphabetically. That means Davita is going to be at the end of our list so far based on the 2 names we have. So her pointer stays the same at -1. Betty's pointer, because she comes before Davita, she needs to point to the index of where Davita is located. We look over here, we see Davita is located at index 0, so Betty is going to point to index 0. Now that we have those pointers updated, we also need to update our start and our free pointer. Our start pointer is at 0. That's pointing to Davita. But if we're doing it alphabetically, we need to update that start pointer. That start pointer is not going to be 0. It's going to be 1. And this is why order in the array doesn't matter. Our start pointer is going to point to what name we're starting at. Once we get to Betty, we can print Betty, look at her pointer, and then go to the next index, which is index 0. To print Davita's name, we see pointer -1. That means we've reached the end of our linked list. The last thing we need to do is we need to update that free pointer because Betty just took index 1. So what's my next available index? It's not going to be 1. It's going to be index 2. So let's add to our add item procedure to account for any name added and not just the first name. When we want to add Betty, the first thing we need to do is actually put her in the list of names. So that's going to be my linked list, free pointer. And what are we putting in there? We're putting in the item that the user just typed in. So we're going to put in that item. The next thing we need to do is we need to set our current pointer to keep track of where we are in the linked list. Well, that's going to be equal to our start pointer, and then our previous pointer is going to be equal to -1. Now we're going to have a short preconditional loop here. This loop will not run for Betty because Betty is not greater than Davita. So we're going to do a preconditional loop. We're going to check and make sure the current pointer is not equal to -1 because if it is, then we've reached the end of the list. But not only that, we're also looking for at the same time that the item that the user is entering is greater than the linked list current pointer. Now there's a couple different ways to write this loop. You can also do the linked list Current pointer is less than item. It's up to you. I always like to put what I'm working with up front. That way it's a little easier for me to read. Then we have our previous pointer. And our previous pointer is going to be equal to what? Whatever the current pointer was. That's going to be the previous, because when we loop around to the next name, or move to the next name, not loop around, but when we move to the next name, we need to know what that previous pointer is, because we may need to update it. Then we need to update our current pointer, and that's going to be equal to our list pointer wherever we are, because that will give us the current pointer. Because remember, we have two arrays, one for the names and one for the pointers. If you're feeling a little confused about how this works, don't worry. When we add the next name that we're going to add, we're going to trace through this code so you can see exactly what is happening. Again, this loop does not run for Betty. It will run for all the future names that we add. Now, if our previous pointer is equal to -1, then what we need to do is we need to do our list pointer. We need to update that. So we're updating Betty's pointer to the start pointer, because the start pointer is 0. We want to update Betty's to 0. That way, after we print Betty's name, we can print Davita's name. That's what that is doing right there. And then we need to update that start pointer as well. And that start pointer is going to be our free pointer, because Betty comes before Davita. Now, if that's not the case, and we want to put this else in the right place here. Now, if that's not the case, if it's not coming after the first item, then what we want to do is we want to do our list pointer. What are we putting inside that? Well, we're going to put our current pointer in there. And then we need to update the previous pointer. And what are we updating that previous pointer to? We are updating that to our free pointer. And then right outside this loop here, or this if statement, not the loop, all we need to do is increment that free pointer. Again, if you're feeling a little confused about what we just added right here, don't, because we're going to add another name and trace through this code so you can see exactly what is happening. Let's swing back and take a look at how it works. So we have that code. We saw how Davita and Betty was added. What we're going to do is add another name, and then we are going to traverse through that code and take a look at how it actually works. So our next name on the list is going to be Clark. To figure out where to put Clark, we know we look at that free pointer, and our free pointer, after we added Betty, the free pointer is now pointing to index 2. So we're going to add Clark. What we're going to do is we're going to take a look at this code. So our linked list free pointer. What's our free pointer? Our free pointer was updated to 2, which means we're looking in the linked list. We're looking at 2. What are we putting inside index 2? We are putting the item. Who are we adding? We are adding Clark. So we look at that free pointer, side index 2. We're going to put Clark. Clark has been added, but our pointers do not work correctly, and that's what we need to go through for the rest of the code so we can update these pointers to work correctly. So the first thing we need to do, though, is we need to set that current pointer. Our current pointer needs to be equal to our start pointer. Well, what's our start pointer? Our start pointer is 1, and that 1 is going to go right into the current pointer. The next thing we need to do is set previous pointer to -1, and that has been done. Once those 3 lines are done, we can move on to our next part of the code, and that is the loop. So the first thing we do is we check this while loop. So while current pointer is not -1, it isn't, and also item Clark is greater than our current pointer. Our current pointer is 1. Is Clark greater than Betty? Yes, Clark is. So we move inside this loop here. We set the previous pointer equal to our current pointer. So what's our previous pointer? Right now it's -1, but it's about to become 1 because the current pointer. So this 1 just copies over in the previous pointer. Then we have to update our current pointer to move to the next item in the list. So current pointer is equal to list pointer, current pointer. Well, we take a look at these list of pointers we have here. We're looking at our current pointer, which is 1. And we can see here, the current pointer we're moving to next is 0, which is going to be Davida. So that's what we're going to compare to next. So we're looking there. Our current pointer becomes 0, and we will be looking at Davida next. So we swing back around. Is our current pointer not equal to -1? Yes, it is. And also, is Clark greater than Davida? No, it isn't. No, it's wrong. That condition is not met, so we don't even do the while loop. We move outside the while loop and continue with our code, which brings us to this if-else statement. So what we're going to do is we check this if statement. If the previous pointer is equal to -1, our previous pointer is not equal to -1. That condition is not met. So what we do here is we jump down to this else statement and we do list pointer. So that's this table right here on the right hand side, list pointer, free pointer. We're looking at this pointer right here too. What is that going to be equal to? That's going to be equal to our current pointer, which is 0. So we need to change this out from -1 to 0. But we're not done, because now we have Betty and Clark both pointing to Davida. We need Betty to point to Clark. So we take a look at that next line of code here. It says list pointer, previous pointer. So we're looking at our list of pointers. Our previous pointer is 1. That's Betty's pointer. We need to update. What are we putting inside Betty's pointer? We're putting in that free pointer too, because we just added Clark. So there it is. Now our pointers are updated. Our start pointer is still, we need to increment the free pointer. So let's go ahead and increment that free pointer. Our free pointer is now set to 3, so we can add another person, which we'll do in just a minute. Let's take a look at these pointers. Our start pointer is 1, which starts with Betty. So far, it's working in alphabetical order because we're only on the first name. But we take a look at Betty. Betty's pointing to index 2. Who's in index 2? That's Clark. Who's Clark pointing to? He's pointing to index 0. Who's in index 0? Davida. So it's in alphabetical order. Let's check Davida's pointer. She's in index 0, and her pointer is -1, signaling the end of the list. So let's add another name. So we're going to add Alfred to our list. To figure out where to put Alfred, we look at our free pointer, and our free pointer is now 3. So let's go ahead and let's add Alfred. So we take a look at this code here. Linked list, free pointer equals item. So we're going to take Alfred. The free pointer is 3. Inside index 3, we're going to put Alfred. And just like that, we're done. We need to reset that current pointer back to our start pointer just to make sure we're starting at the beginning. Because when we left off with our last name, current pointer was set to 0. That is not our starting pointer. So it's very important you reset that current pointer back to the starting pointer, which is 1. So we're going to get rid of current pointer, and we're going to put in the value of 1. And then the previous pointer. You may be saying, why did we set it to -1? Because our previous pointer here is 1. We have no idea to predict when a user is going to add a name or what previous pointer is always going to be. So we're going to reset it back to -1 here. And now we are good to go. And the reason we want to set previous pointer back to -1 is in case it's going to be the first item. Alfred comes before Betty. So this is why it's important, and to make sure we're doing the first item. So while the current pointer is not equal to -1, it's not, it's 1 right now, and item Alfred is greater than our current pointer. Is Alfred greater than Betty? Alfred is not greater than Betty. This condition is not met, so we don't even enter the loop whatsoever. We jump straight to this if statement. If previous pointer equals -1, guess what it does? And this is why it's so important, because if we didn't reset it, it's going to run this else statement, and we're not going to have all the updated pointers that we may need somewhere down the line. So we're going to go through this if statement right here. So we take a look at our list of pointers. We're looking at the free pointer index. My free pointer is 3. So I'm looking right here at this -1, which is Alfred's pointer. Alfred is not the end of the list. We need to update that. So we're updating that pointer, -1, to our start pointer, which is 1. Now Alfred is pointing to Betty, but Betty is still our starting pointer. Well, that's what the next line of code does. It updates that start pointer from 1 changing that out to 3, which is Alfred. So now when I traverse the list, it'll go Alfred, because that's my start pointer. Then it will go to Betty, Clark, and then Davida. Now don't forget, we also need to update that free pointer, so when we add our next name, we can put it inside index 4. So let's traverse an output so we can see how the code works, and now it's time to put it to the test. Our code looks like it works. We need to put it to the test, and we need to output it. So we're going to write a procedure that's going to print the list, but we're going to add something extra that allows us to print the array too, so we can see how the array contents are different from the linked list. Let's switch over and let's code out that print list method. First thing we want to do in our submain is we're going to run a for loop that calls add item 5 times. We're going to add all the names. Then we need to call our print list method. Down here, I've started our print list method. This part has nothing to do with the linked list at all. What we're doing here is we're showing what our start pointer is. Then we're printing the array. We want to see how are the array contents different from the linked list, because our linked list, when we traverse it, should be in alphabetical order, and the order of the array doesn't matter. So that doesn't have to be in order. The only order it's going to be in is when we enter each name, it's going to be in the order where we entered each name. The first thing you want to do when you're traversing that linked list, you want to set up that current pointer. What is that going to be equal? That's going to be equal to our start pointer, because we want to start with whoever has the least name alphabetically, which in this case should be Alfred. Once you have that set up, you're going to use a while loop. And we want to keep looping this while the current pointer is not equal to -1. What does that mean? That means while we are not at the end of the list, because once we get to the end of the list, we don't need to try to find the next one. So we're going to output the linked list name. So we're going to do console.writeLine. We're going to output that linked list, and we're going to do I, because we want to output that person. Actually, it's not I, excuse me, it's current pointer. And we want to say points to index, and we want to say the index that it points to. That way we can see its pointer to make sure it's pointing to the right thing. So I'm going to get my list pointer array. What am I doing? I'm looking at that current pointer. That's the index I'm getting. So this current pointer will give me the name from the linked list array and its pointer from the array of pointers. The next thing I need to do is I need to move to that next pointer, which means I need to update current pointer. Where am I getting that pointer from? The list of pointers and wherever we currently are. That will print out the entire linked list in order. So we're going to save. We're going to run our code. We're going to make sure it prints out in order. Okay, what name do you want to add? Let's add Davida's name. The second person we added was Betty. Then we added Clark. Then we added Alfred. And then we didn't trace through how to add a 5th name, and that's because it's all going to work the same way. We proved it twice, so we don't need to do it again. Otherwise, this video would be hours long. We add Elijah. Now, when we print this and we see the array, we should see Davida, Betty, Clark, Alfred, Elijah. That is fine. When we traverse the linked list, going through that while loop, we should see Alfred, Betty, Clark, Davida, then Elijah in alphabetical order. So here we can see index 0 is Davida, Betty, Clark, Alfred, Elijah. It's in order. This part is the array. Now our start pointer is 3. So we look at 3, that is Alfred. Alfred points to index 1. Well, if Alfred is pointing to index 1, then next name is index 1, Betty. That works. Then we take a look at Betty's pointer. She's pointing to index 2. Who's in index 2? That is Clark. Clark points to index 0. That is Davida. Davida points to index 4, which is Elijah. So, and then Elijah points to index -1, which means that is the end of our linked list. All right, the last thing we need to go over is how to remove an item from the linked list. Now, when we remove the item, what you're actually doing is not actually removing it. You're adjusting the pointer so the index is skipped over. So let's code it out, then trace the code so we can see what is actually happening. So we have our procedure, remove item. Item as string, found as boolean, asking the user what item do you want to remove. We're going to store that in item found, we set the false, and then we start traversing the list and look for our name we want to remove. Remember, anytime we're starting our linked list, we are going to set our current pointer to the value of start pointer and our previous pointer at -1 for the very first item. Now, we're going to use a while loop, just like we've been doing, to traverse the linked list. If our current pointer is not equal to -1 and found equals false, well, that means we haven't found the item and we are not at the end of the list, so we need to keep searching that list. But if item equals our linked list current pointer, then we have found our item, so found equals true. Now, inside this if statement, there's a couple things we need to check for. One, is it the first item that has been removed? If it is the first item, Alfred, that needs to be removed, or if Alfred's already been removed and it's Betty, then we need to update our start pointer. So all we're going to do is check if it's the first item. How do we do that? Well, we check that previous pointer and we look to see if that previous pointer is equal to -1. If we do, then all we're going to do is take our start pointer. What are we going to set that equal to? Well, we want our list of pointer arrays. And who are we setting it to? Well, that's going to be the current pointer index. That's if it's the first item. Now, if it's not the first item, then what we want to do is we want to record the previous value into our list pointer. So we need to update that previous value. So let me show you what I mean by that. We have our list pointer, and you want to put it in the right spot. So we're going to have our list pointer. We're updating that previous pointer so we can skip over the next name. And what are we putting in that? We're just grabbing the pointer from the person we are looking for. So that's going to be this previous. There we go. So that's going to allow us to do that. Now, there's another possibility that's outside these if statements right here. So right here, we're going to do an else, because if it doesn't match, then we need to move on to the next item. So how do we do that? Well, we need to record that previous pointer. That's going to be equal to our current pointer, so we can move on. And then we update our current pointer, and that's going to be equal to whatever name we're at, whatever index we're at, we're going to grab that pointer. So that right here will allow us to traverse through and remove any items. This set of if statements right here is if the item is found. We're updating the pointers. Again, this part right here is if the item is the first item. This is if the item is not the first item. All we're going to do now is we're going to do a simple message. We're going to do if found equals true. Then we're going to output a message saying the item or name was removed. And then we just use a simple else statement. And we say the name is not present in the array. And just like that, this will allow us to remove some items. But let's take a look at how this code actually works by tracing this code out with a couple examples. So let's go ahead and trace through this code and make sure that it works. The first thing we need to do is load up current pointer with the value of start pointer, which is 3, and that previous pointer to -1. Now we are going to be removing Alfred here, which is the very first item. So that is who we are removing. So item is going to be set to Alfred. So let's go ahead and take a look at this condition. While current pointer is not equal to -1, it's not, it's 3, and found as false. That condition is met, so we're able to go inside the loop. So we look at this first if statement. If item, Alfred, equals linked list current pointer. Well, my current pointer is 3. Alfred does equal Alfred. So what we need to do is we need to update the value of found. Found is no longer false. Found is now going to be set to true because we found who we are looking for. The next thing we need to decide is this the first item in the linked list, or is it later on? Well, because Alfred is the first item in the linked list, we check that previous pointer. If that previous pointer is -1, and it is, we need to update our start pointer, because our start pointer isn't going to point to index 3, which is Alfred. What is it going to point to? Well, we need to check Alfred's pointer to see what he points to next, and that is what we will assign as our start pointer. Our start pointer originally was 3, but I'm going to look at Alfred's pointer, and I see he has a pointer of 1. That's going to be my new start pointer. He was pointing to Betty. Well, now because we've removed Alfred, yes, he's still present in the array, but notice no item is pointing to index 3, including our start pointer. That means Alfred will never show up when we traverse the linked list. Let's go ahead and let's remove Clark. Now, when we remove Clark, remember Alfred has already been removed, so our start pointer is going to be pointing to Betty, but we're going to be removing Clark this time. So we set up that current pointer to our start pointer. I take that start pointer of 1 and I slide that value right in the current pointer, and then I make sure previous pointer is equal to -1, and it is. So our current pointer is not -1, found as false, so we jump right into this first if statement. If item equals linked list, our list of names, current pointer. My current pointer is 1. Is Betty equal to Clark? Or actually is if Clark is equal to Betty. It's not. So I need to jump down to this next else statement because this if statement condition is not met. Well, now that I'm at the else, I need to do a couple things here. The first thing I need to do is update my previous pointer to my current pointer, which is 1. And then my current pointer, I'm going to get my list of pointers here, my list of pointers, and then the current pointer is 1. So that means my next pointer is going to be 2. I'm going to check current, index 2 instead of index 1 because we just checked index 1. Now, because the condition is still viable, I need to go back up, check it. Current pointer is not equal to -1, found as false. That means we are on to the next item. So we check to see if Clark is equal to linked list, my list of names, current pointer. My current pointer is 2. Is Clark equal to Clark? By golly, it sure is. So found is going to be set to true. So I'm going to change it from false to true. That will allow us to exit the while loop here. And we're actually going to exit it a little early with this else statement down here because my previous pointer is not -1, it's 1. So that condition is not met. So we jump down right here to this else the else statement. So my list pointer, previous pointer. So my list pointers, my previous pointer was 1. I need to update this pointer right here. I need to update it from 2 because we're no longer going to Clark. We're removing Clark. No, that doesn't remove him from the array, but it skips over him. So when we traverse the linked list, we never see Clark's name. We update it to 0. So now with our start pointer, we're going to go to Betty. Betty is going to go to Davida, and then Davida is going to go to Elijah. It's okay that both of these equal 0. But remember, Clark's been removed, so we don't need to update Clark's pointer. We just need to make sure we're not pointing to him whatsoever. So we hit the exit while. That will allow us to leave the loop a little early. What we need to do now is run our program and do a final check to make sure it all works. Before we test our program, what we need to do is we need to go back in the submain. I have 3 remove items. I called it 3 times. The second time is to test the else statement. We're looking to see, make sure our name isn't in the list. So we're going to type in herb computer science for that one. Then actually remove a second item, print the list, check the pointers, make sure they work. Now, because we've already tested the first one, you can put these names in any order you would like. So I'm going to go ahead and type them in. Davida, Clark, Alfred, and then Betty. So we can see right here, Alfred, Betty, Clark, Davida, Elijah. If you would like to double check those pointers, you can. If you're taking your paper 4 exam, you are allowed to test your code as many times as you would like. And they're not going to know how many times you checked your code anyway, so it doesn't even matter. But please, please test your code. All right, what item do we want to remove? Well, up first, we're going to remove Alfred. Then we're going to try herb computer science. We should get a message saying name is not present in the array. It's actually not present in the list. That's what we should say. And then we're going to remove Clark. Now, these pointers should be updated. Notice our array still has the names, but it's not about what's present in the array. It's about traversing the linked list and checking those pointers. So we can see Betty, Davida, and Elijah are in alphabetical order, which means our start pointer was updated correctly, as well as Clark when we skipped over him. So let's double check these pointers. Betty points to index 1. What's in index 1? That is Davida. Davida points to index 0, which is Elijah, and Elijah points to index -1, signifying the end of our linked list. Hope you guys found this video helpful. If you did, make sure to give it a thumbs up and subscribe to help the channel grow, and we'll see you guys in the next linked list video.